reaction is. So just look at the reactant. We have given with secondary butyl lithium. We know that it can act as base. And what is the function of TMDA? Do you know that it is very, very important? Tetramethylene diamine, which act as chelating agent. Okay, which act as chelating agent. And here you can see that. So secondary butyl lithium can accept electron from that. Sorry, it can accept proton, acidic proton. You can see here we have acidic proton, and here we have acidic proton. And where should this secondary butyl lithium can accept? Okay, so this is the question. Where should it takes up acidic proton? And if you know that, if you have the basic command, then you will give the correct answer for this problem. Okay, so tetramethylene diamine can chelate with lone pair of electrons on methoxy oxygen and interact with this amide oxygen, and here is the chelation. So the secondary butyl lithium should only abstract this acidic proton, not this proton. Okay, so this is the concept, a deep concept involved in this problem. Okay, right. And due to the chelation with this methoxy oxygen and amide carbonyl oxygen, so secondary butyl lithium only deliver from this way, so which can abstract this acidic proton only. Okay, and that's why here is a negative charge. Now just draw the structure. Here methoxy group, here is a methoxy group, and here Ne2. For example, if secondary butyl lithium attack from here, there is no chelation because this methoxy group is far away. Okay, so that's why. So here is a that means acidic proton abstracted by the secondary butyl lithium from here only. And after that, this negative charge attack on trimethyl silyl chloride. So attack here, and chlorine just moves out. Okay, so in the next step, just try it. OMe here, and here trimethyl silyl group, here is CONET2. In the next step, we have given with n-butyl lithium. So there is only one way to abstract more acidic proton. So here is acidic proton that should be taken up by this n-butyl lithium, and here is a negative charge, and this negative charge attack on methyl iodide and produces simply methyl group here. So just draw the complete structure in a neat way. Okay, not like this. Okay, CONE2, here is the methyl group. And after this, fourth step is bromination. That is, a trimethyl silyl group is substituted with bromine. Okay, and simply it produces, that is, silicon bromine exchange is simply observed, and or simply bromine can attack on silicon and further attack replacement of trimethyl silyl groups takes place, and to produce the final product of bromine. Here methoxy group, here is a methoxy group, here CONE2, and here is methyl group. This is the final product. You can see fourth option is the correct answer. Okay, so what is the main concept or deep basics involved in this problem to give the correct answer? Simply the first step, that is, where should take the acidic proton. Okay, that is a point. It is decided by tetramethylene diamine. Okay, right. And next question. So here, the major product X and Y in the following reactions. Just look at the given reactant here. So we have given with n-butyl lithium in one reaction. Next case we have given with LDA, lithium diisopropylamide base. Both are the bases. Then what is the difference? Okay, so simply just remember that bromine and lithium exchange is observed, which is popular. Okay, bromine lithium exchange is popular with n-butyl lithium base. Okay, so in the hexa, that means in the right side equation, we can say that bromine and lithium exchange takes place. Here is the lithium. Okay, right. In the hexa, we should look at this. Right, and in the next case, lithium diisopropyl amide. Here, lithium hydrogen exchange. Okay, lithium hydrogen exchange with amide bases like here we can say LDA or lithium TMP. So like amide bases, whenever amide bases are used, lithium hydrogen exchanges can be seen, but not a bromium lithium exchanges. Okay, just note these important points. And from this we can simply say that here the more acidic proton is observed from here. Okay, so that's why this proton only picked up by this LDA and gives the next step of the reaction. Right, there will be no change or no reaction with that bromine. So when you apply butyl lithium, only bromine and lithium exchange observed. When you apply LDA, so there is no bromium and lithium exchange, but the acidic proton is picked up by that LDA. So lithium plus and here is the minus. Okay, so option 3 is the correct answer. And next question. The major product X in the following reaction. Just look at the given reaction here. So we have given with, which is this? Tebbe reagent. Okay, it is called Tebbe reagent. Now try to expand this reagent. Here is Cp, here is Cp, here CH2, here aluminium. Okay, sorry, here is the chlorine and here is aluminium. So this is simply considered as Tebbe reagent. Tebbe reagent is a methylinating agent. So just note it, methylinating agent. So that means that carbonyl groups are simply methylated to produce like alkene. Okay, so this is the main concept involved in this reaction. Right, here all of them react. So aldehyde react to produce CH2 and ester just produce CH2 here, right? And in the third case, so whenever the CH2, that means this reagent attacks, produces, that means here vinyl ethers can also react with this Tebbe reagent and produces this product. Okay, and here we have amide also, amide carbonyl group also produces this CH2. Okay, so simply Tebbe reagent can react with almost all carbonyl functional groups and simply methylinate them. Okay, right, so here what is the correct answer? Simply fourth option is the correct answer because all the given functional groups are reacting with Tebbe reagent. That's why fourth product is the correct one. Okay, right. And next question. Match the following. Here we have given with so reagents, different kinds of reagent with their names and their structures. The first one here already, so we have given in the previous one, that is which is indicating Tebbe reagent. Okay, and second one, so second one is a Krebs reagent, and third one which is a Petasis reagent, and fourth one which is Takeda reagent. Okay, so all these reagents act as methylinating agents of carbonyl functional groups. Just remember this. Okay, right. And next